Hello, everyone. So, thanks for joining. So today I'm together with Claudio Serrano from SUSE. I also worked for SUSE in the past. So we've been colleagues in the past, so I'm happy to work together with him today here. We are talking about how to implement security at scale together with SUSE Venture, Vector, and Vault. So to give you an overview about the general challenge, so this is agenda. First, we will talk about the general challenge. We will give you an overview about the solution. We will give you a demo, and at the end, we will do some conclusion, and we hopefully have time for Q&A. As I said, unfortunately, we have started later because the invitation said 9 a.m. and the website said 10 a.m. So we expected to start at 10 and not at 9. But yeah, no, we're just starting. So okay, so what is the challenge? Kubernetes is so great, yeah. So everybody thinks here Kubernetes is the solution for everything. Unfortunately, it's not that easy. Yeah, I would say there is no other open source software with so many memes out there. If you look at this here, it's hilarious. And the catch is that Kubernetes is a tool to orchestrate containers. It's not a turnkey platform. So you basically need to have something around it. Yeah, Kubernetes itself is not sufficient to operate itself as an environment. So I will hand over to Claudio now.
Hello, sorry, I can't show my camera for some reason. I'm unable to share my video. So in case people want to see me, but if not, it doesn't really matter. So do you want to try to give me the, see if I can actually start the video? Because to me, it says I cannot start the video because the host has stopped it. So maybe we just leave it as it is, no problem.
I have no idea.
Okay, so no problem. So basically, so my name is Claudio anyway, Claudio Serrano. I'm a solution architect at SUSE. And basically, I'll concentrate on everything that's actually cloud native. So containers, Kubernetes, and security and so forth. So I've got a few slides, as Carsten said, I've got a few slides to show. And also then we're going into the specific demo. So first of all, let's start by looking at a couple of slides of the security challenges. So with containers increasing popularity, it's therefore made it a lot more attractive for attackers. So basically a cloud native annual survey was held last year, and unsurprisingly, the results were that security is one of the top challenges for organizations running production workloads naturally. And of course, the natural costs associated with it, as you can see, and I'm not even taking into consideration companies' reputation as well. You're going to get a copy of these slides anyway at the end. Next slide, please. So some top challenge headers, some top challenges, some headers around container security. I mentioned previous slide, increasing popularity of containers, more attractive for attackers. So both vulnerability and compliance awareness and management are extremely important. And it's also important to shift left your container security implementation approach by already adding security best practices, therefore security as code, into your supply chain, as you will see afterwards. And of course, the east-west internal container traffic is as much of a security concern, if not more, than the traditional north-south external incoming traffic via the existing firewalls that you may have in place. And really, you know, we really need to know what is talking to what within your cluster and outside your cluster scope. So really, traditional security tools as we know them today for the old world, it's basically don't work well in these environments. Next. Furthermore, we should start really thinking the approach to our security strategy. So in essence, we should be taking and treating each container as its own security boundary. So start taking this zero trust approach, meaning by default, nothing is trusted or approved as a workload and therefore should not be trusted and therefore denied access. We also need to automate all these activities by introducing security as code so that these security policies can be deployed to other clusters and even being provided to the development teams, as I said, to have the required security already injected into their development pipelines. So we shouldn't be creating firewall rules or communication rules for our containers on an individual basis, as this is just not scalable, particularly when you have a dynamic environment of hundreds and hundreds, even thousands of containers running in our environments. And yes, when it comes to containers, layer 4 simply is not enough. I mentioned that we can't just make firewall rules based on ports and IP addresses. So as you know, Kubernetes is far too dynamic and ever-changing at network level. So, and therefore we need some upper level of abstraction and protection, such as being able to provide layer 7 inspection and detection. Yours, Carsten.
Yeah, sorry, the unmute button was hidden. Yeah, I think one thing which is important to understand, if you are experienced with Kubernetes, there are several types of resources, and there is also a secret resource. Yeah, but Kubernetes is not a secret management system. So if you store a secret in Kubernetes, it's stored in etcd. It's stored completely unencrypted. There is no mechanism to rotate secrets built in. They're only base 64 encoded. Everyone who has access to the namespace or the cluster scope can read these secrets. So there is no fine-grained role-based access control on top of that. And there's, yeah, as I said, there is no dynamic, there is no short TTL possible. It's also quite hard to audit who has access to the secrets. Even Kelsey Hightower, who is, I would say, like Mr. Kubernetes, one of the people who started Kubernetes, invented it, says that Kubernetes is not a secret management tool. And if you look into the most, if you look in some data here, most breaches start with stolen credentials. So keeping your credentials secure is quite important. So we had an increase of 380% over the last 2 years of data theft breaches. 47% of these breaches involved a human element. 9 out of 10 of web applications breaches consisted of stolen credentials. And 62% of these intrusions involved the supply chain. There are several cases where at the end of the day, a third party or the supply chain was involved because they had elevated credentials or access to some credentials. So this is quite important. So now we started with the introduction. We gave you an overview. Now let's have a look into the solution itself. And I will hand over back to Claudio.
Thank you, Carsten. So let's have a look at a top 1,000-foot view at Kubernetes. So as we probably all know, once we start deploying Kubernetes clusters, we may start with a couple of clusters in your data center and also a couple on the hyperscalers. And managing these few clusters is not so much of a problem. But eventually we're going to come to the issue that we're going to start having many Kubernetes clusters, different environments, distributions used by different teams, and they may have different hardware capabilities, different geographical locations and environments. As I said, cloud, on-prem, on the edge. Soon enough, the management of these combinations can become quite daunting and complicated. So how are we going to manage all of these clusters in a unified way? For example, how are we going to implement things like identity and access control? How are we going to do role-based access control? How are we going to monitor these? How do we back up these clusters? How do we rotate certificates? How do we integrate storage and so forth? Next. Next slide. Thank you. So SUSE has a set of cloud-native solutions within the enterprise container management portfolio to address everything that you need to run and manage your container workloads. So shown are the solutions that are embedded within the portfolio and all fully integrated. As part of today's webinar, I'm going to concentrate on Rancher Prime for the Kubernetes management and NewVector Prime for the full lifecycle container security, which also has context into secrets as well. There's also other technologies, as you can see, Longhorn for cloud native storage, bare metal provisioning with Elemental, converged infrastructure. You can manage all the VM workloads and Kubernetes workloads, as well as Stack State for the application monitoring and observability, which is very important. Next slide. So, mentioned before, the solution, as I said, you're going to get these slides. The solution overview that I'll provide today is Rancher and NewVector. I'm not going to go too deep into the solution capabilities because that's not the aim, but I want to highlight some of the capabilities in the next slides, as it will help you understand what's going on in the demo. Next slide. So, Rancher, open source Kubernetes management solution designed to provide cluster lifecycle management. So it doesn't matter if they're on cloud, private cloud, or edge, manage hundreds of these clusters through a single interface, okay? Manages any CNCF certified distribution, including all the hyperscalers. So the feature function is quite extensive. I'm not going to go through it all. Once again, it's not the aim of it. But it also, for example, has GitOps support, allowing to define how applications are deployed, and that's what I've done also in the demo. I mentioned the role-based access control, authorization into clusters, which of course goes hand in hand with container security as well. Next slide. Apart from management of clusters themselves, SUSE also has a couple of distributions, Kubernetes distributions, fully 100% upstream Kubernetes, CNCF certified, logical implementation of zero-time upgrades. So as long as your applications are designed in a fault tolerant way, then these upgrades can be performed to these clusters without any downtime to the applications. I mentioned the backup and disaster recovery facilities. So it's really all-in type of getting Kubernetes cluster up and running in the productive environment with elements such as core DNS, CNI plugins, ingress controllers, and so forth and so on. Next slide. So let's continue with SUSE NewVector, right? Next slide. 1,000-foot view again on NewVector. So as far as automating security policies, NewVector Kubernetes native container security solution, comprehensive risk profile of known vulnerabilities, and delivers immediate automated protection for both known and unknown vulnerabilities. You're going to see this later on. VIP network visibility is the most critical part of any runtime container security product. So inspecting container network traffic tells us how an application communicates with each other's applications, and it's really the only place that can stop attacks before they reach the application and workload. Zero trust, we all heard about this new wave, new magic word, zero trust protection. So basically, we like to ensure that we start enforcing security and compliance requirements in modern cloud-native pipelines as well. So the increased attack surface of container infrastructure makes security even more important. So NewVector starts from the left-hand side of development with the vulnerability and compliance scanning, then progresses to the right with real-time network, container, and host protections. And of course, compliance. Compliance is a critical concern as organizations move to Kubernetes and new infrastructures. So what was straightforward in legacy infrastructure, like the VMware world in perimeter-based network security, becomes more complex in these modern hybrid environments. So NewVector offers the detection capabilities and security policy enforcements, as you're going to see in the demo, and simplifies this reporting compliance such as PCI, GDPR, NIST, so forth and so on. Next slide. NewVector can be split in a very simple manner into supply chain security and runtime security. So supply chain security, all your vulnerability and compliance scanning, as well as into admission control, meaning the control mechanism of what can be deployed to a cluster when. So the supply chain is where we're securing the supply chain of your CI/CD pipelines, scanning for CVE vulnerabilities, other security settings within, and scanning at different points within the software development lifecycle. So for the compliance scanning, Scanning, as I said, against the normal compliance regulation, GDPR, NIST, PCI, and so forth. And for the emission control element, which also we're going to show in the demo, we're doing some unique things. So we're extending a little bit more than the native Kubernetes emission controller. So, for example, to prevent vulnerable images from being used on the cluster, like, for example, that there are no images deployed on the cluster without, for example, OS categorization. We're checking for images if they've got a signature, checking for container runtime profiles, checking that, for example, containers cannot run as root or restricted, or even restricting privileged container deployment, right? And even checking if an image that we're trying to deploy already has a fix, or if a CVE has a certain high score, okay? So the second time is the runtime security. Still pretty much the same thing as you see on the top, taking into account vulnerability, compliance scanning, but doing this at the end of the supply chain. So when containers are now running in your cluster. So next slide. Okay, so that slide basically just shows that all the CV database sources that we actually consume on a nightly basis and we injected within our CV database in order to do the scanning there. Next slide. So I told you about this concept of shift left approach. So within our vulnerability and compliance management, so we're full life cycle. So we start when the developer builds an image, and we'll have plugins for Jenkins, Circle CI, and others. So therefore, we can pass or fail builds as part of the pipeline, and we can scan registries as you might expect. And then we also plug into admission controller and therefore create security policies for deploying the containerized apps. And naturally, at the end of the day, we want to make sure that we continuously scanning in production to find new CVEs as they're published, which is basically on the right-hand side where it says runtime. So as you can see, we have gates at every single one of the CI/CD pipeline, the registries, and as well as into the runtime component. Next slide. So we talked about supply chain security. Now let's get a little bit deeper into runtime security, and then I'm going to hand over to Carsten. And the runtime security, we look into two different areas. So these are threat-based controls on the left and zero trust controls on the right. So on the left, threat-based controls, these can be resumed as well-known threats. And these basically need a signature for matching, which are usually provided by the vendors, as you saw in the previous slide, right? Okay, all these vendors were actually providing these CV sources, yeah? So these threat-based controls do activities such as scanning for known CVEs, scanning for data loss protection and network attacks, and looking at traffic that looks like, from the data loss protection concept, looking for traffic that looks like credit card information or other personal ID information such as social security. Also, we do the OWASP top 10 threats, so the Open Web Application Security Project, which has listed the top 10 web application threats, and we do this with live traffic running. On the right-hand side is where NeuVector differentiates. So we have, once again, the magic word zero trust controls. And these also have a signature for matching, but this signature is not based on the vendors, it's based on your own application behavior. As you can see, you're going to see on the demo, NeuVector automatically learns all the network, process, and file access behaviors, and then it can automatically generate security policies for those specific behaviors, and therefore helping you protect against anything that is not in your known behavior. So therefore it's known in the concept of zero trust. I think the demo will make a lot more sense than my words. Carsten, your call.
Okay, thank you, Claudio. Yeah, we learned now from Claudio how NeuVector can restrict access between pods, etc., and how to detect vulnerabilities and stuff like that. And I think the demo is quite exciting. Now let's have a look into the secret management side. So I said that Kubernetes is not a secret management solution, but Vault is. So we have created HashiCorp Vault, and the idea behind Vault is to have a solution which authenticates and authorizes every access request. So in a dynamic world, yeah, you can't rely on IP addresses. You don't have trusted networks any longer. So therefore, you need an identity. You always need an identity, and you always need to authenticate and authorize. And the logo of Vault is a triangle, and I really like this example to also explain it like that. Basically, Vault is meant to be used for application to application secret management. So that means if your web server requires a secret, sorry, access to database, for example, so it needs credentials. How does it get these credentials? For example, in Kubernetes, it would be a client. It can identify as a Kubernetes service with a service account. It authenticates to Vault. Then, based on policies which are matched to this identity, the Vault will then decide if you have access to these credentials or not, and then it will return these credentials and give you access to it. And that's the whole idea, to always have a system between multiple ways to authenticate your workload, different types of secret engines which can be used, and then everything based on policies. It can apply these rules and give you access or deny the access to the secrets. So Vault itself is meant to be used completely automated. In the best world, you don't have to care about it at all because you have automated everything. So you don't have to care about secret management as soon as you've automated everything. And Vault does more than offering access to static credentials. Yeah. So of course you can use Vault to manage static credentials, like you can store them. You can store key value pairs in Vault as well. But the real benefit of a secret management is when secrets are dynamic. The best secret is a secret which nobody really knows, which is always rotated, has a short time to live, and is automatically rotated. So therefore, rotation is one of the I would say crucial features of Vault, offering dynamic secrets like dynamic database secrets. So they are created just in time instead of stored somewhere in a key value pair. Vault also can offer private key infrastructure certificate management for your applications, and almost everybody of us had a problem in the past work that you had a web server and certificate just timed out, had reached its end of life, and then the workload was not accessible any longer. And with Vault, this should not happen again. Yeah. Vault also does support advanced data protection stuff. Yeah, it does support KMIP. It can act as a soft HSM. It can be used to simplify and standardize your encryption. Can create signatures, tokenization, etc., etc. Vault can be consumed in. Sorry. As I said, I have COVID. Vault has can be consumed in multiple different ways. So for small and medium-sized businesses, we recommend our cloud-native architectures. We have HCP Vault Secrets, which is, I would say, currently a stripped-down version of Vault, but it's completely multi-tenant environment. So you don't have your own cluster. You can just store secrets in this. And together with that, we also have HCP Vault Radar, which is a scanning tool which can scan your Git repositories, your Jira, etc., for exposed secrets, and then give you tips how to remediate that. And most of the times, customers want their own dedicated clusters. For this, you can use HCP Vault Dedicated, which is our SaaS offering of Vault. So with this, you can select where you want to deploy this, in which region, on which cloud provider you want to deploy this, but it's completely managed by us. So you don't have to care about updates, etc. It offers you the full functionality of Vault, but as a managed service. And last but not least, we also have Vault Enterprise, which is the self-managed version. Yeah, same functionality as HTTP Vault Dedicated, but it's self-managed, so you can install it yourself, you maintain it yourself. That gives you more flexibility, but also more reliability, because you have to care about updates, etc. Let's have a look at how Vault solves these challenges. So in the beginning, I said the problem is that Kubernetes just stores stuff in etcd. So every secret is just stored completely unencrypted in etcd. And that's a security risk, of course, yeah, because everyone with access can read the secrets. So therefore, we've created a secret engine, especially for Kubernetes, which can be used to create service account tokens, service accounts, role bindings, etc. dynamically. And this then, with this, you can, together with the authentication method for Kubernetes, you can configure your Kubernetes services to identify against Vault as a Kubernetes service. So now we have taken care about the authentication side, but how do we get secrets into Vault? And there we have several methods. One method, which I would say is one of the best methods, definitely, is to use a sidecar container. We have so-called Vault agent injector. If you're familiar, maybe if you're familiar with Vault, you might know that we have Vault agent, which you can normally run manually next to your workload to inject secrets into, for example, configuration file dynamically, with a placeholder. With Kubernetes, it's very easier to use that, because with this we have the sidecar injector. You just create annotations, and then the injector, the agent will spin up as a sidecar container automatically, and then will inject secrets directly in the container into the path which you've configured. Another option is to use a Vault secrets operator. So we have created an operator for Vault, which you can use together with Kubernetes. At the end of the day, what this does create is, at the end, it's a secret resource in Kubernetes. So the secret will be stored in etcd again, but with a huge benefit that the overall management of the secrets is done via Vault. So you can rotate the secrets from Vault. You can even use dynamic secrets, etc. Yes, the secret will be stored in a secret resource, but Vault has a control about it. But that, to be completely honest, that does not change the way how robust access control gives people access to the secrets. So at the end of the day, it's up to you to decide if you want to use this or the agent. I personally prefer to use the agent, because it makes a lot of stuff way easier than using the operator. There are other ways as well. I've just explained the first tool here. You can also use the CSI and mount secrets through the container storage interface into a container. Or if your application developer is aware of Vault, of course, they can also directly use the API and use a library, for example, Python library, etc., to directly talk with Vault. That's also possible, but that has nothing to do with Kubernetes. So that means that your application natively supports Vault, but that's also an option, of course. Okay, so now we're heading to the demo part, and Claudio will start first. So I will stop sharing my screen now, and Claudio, I will hand over to you.
Thank you. Let me see if I get this right. Okay. See my screen okay? Can you confirm, please?
Yes.
Yeah,
So, sorry, I nodded, yeah, but I muted
you have a
myself.
problem with your mute button. Okay, no problem. So thank you, Carsten. That was very well explained because it goes right into. So, for today's demo, I'm going to be using the Rancher Prime as basically before, and New Vector as well. So let's take the context. Let's start from the beginning so you know what I'm going to show you at the end with New Vector, right? So I'll be using Rancher Kubernetes engine, right? So basically, I've got a cluster here called CS Demo. It's a Rancher Kubernetes engine cluster, and it's got various workloads, including a WordPress application that's been deployed with secret environment variables hard-coded within the image itself. As we heard before from Carsten, how it's important to have secrets management done outside the specific image and outside Kubernetes itself. So let's go into the specific my cluster. I click on Explore. And this is a live demo. So of course, we always got to pray to the demo gods, but it should be fine. So within my cluster itself, so I've got various objects that can be managed and manipulated. So today's webinar is aimed at secrets management and container security. I will spare you the whole Rancher Prime capabilities. But before anything else, I mentioned that I have a WordPress application. So let's look at this application. I go into workloads. I see deployment of a WordPress application, and I see the respective pods, basically the application server and the actual database itself. Okay. Of course, this service, you can access it from your side. There's an ingress associated with these services, WP, demo, so forth. And I'll click on it and I see that my WordPress application is up. So you can see this is real life. Okay. So let's look at the security of the cluster itself. Okay. So I go into New Vector, basically, as you see, fully integrated. And I'm going to click on that. And here I come to the respective dashboard with various elements, as you can see. Okay, my 1000-foot view showing all the security elements, such as the overall security score. Then you've got the ingress and egress exposure, for example, runtime security events, top vulnerable pods, and so forth and so on. This is an aggregation of everything that's actually been collected by New Vector. So under network activity, I see a graphical view of how my applications and therefore microservices are running within my cluster itself. I've got quite a few there at the moment, but I can actually filter down just to show me a specific namespace. And I've got a microservices application that's auto-generating traffic at the back. And here it's being drawn out. And for example, I can try to click on the link, and hopefully I can see the traffic, external traffic. So this is basically from my IP address down to the actual pod itself. So this is just a graphical representation of everything that's been discovered, which I'm going to go into more details afterwards. So under assets itself, so this is everything that's actually been basically scanned, right? So under assets itself, I see the actual platform. So basically, this is my Kubernetes Rancher 127 version. There is no CVE scores. This is the database that I'm actually using. Under namespaces, I see all the namespaces running within my cluster. Under nodes, and this is where it's going to get interesting, these are basically the worker nodes providing the infrastructure for my Kubernetes cluster. And here we already start seeing something interesting, right? So I can see vulnerabilities and compliance. So these vulnerabilities here, even though this is a container security product tool, these are basically issues found, right, within the OS binary installed, like one of the OS binaries installed under Ubuntu. Nothing to do with Kubernetes. But as you can see, the tool also gives you a list of the CVEs and the respective score, right? As well as the version and specifically maybe which version it's actually fixed on, okay? Right, okay? So this is a very old version of Ubuntu, but I had needed some sort of traffic to actually, needed an old version of an OS in order to show you what the tool is actually capable of. The same thing for compliance. So under containers, this is where we start getting on the Kubernetes world. I see all the containers running on the cluster. So since I've got lots of containers here, let me just go and look for something a little bit more, drill down a little bit more. And let's look at a recommendation service, which is basically a microservice running on that graph that you actually saw before. And here, basically, I'll start looking at the CVEs, right? So these are the CVEs that are actually running within the image of this container itself, okay, within this specific pod. As you can see, I've got the list of the CVE. I can actually click and, I can actually go down and see what the CVE is. Not very interesting, but what's interesting here is actually says that, for example, this CVE is running on this specific version, this Linux libdev. This is the version running, and this is where it's actually fixed, okay? So furthermore, apart from the CVEs, we're also running against the CIS compliance rules, and we can actually see this Docker image has got a rule D4.08, which comes from CIS, and it tells you what the error is. So this is a great way of actually seeing all this, okay? All being automatically scanned without any code needing to be added to your applications. All this discovery that you saw from the CVEs and the compliance is simply done by, when you install new Vector, click on the auto scan tool. And then, of course, new Vector is going to discover all the network traffic, as I said, the east-west traffic, if you remember from the presentation. So apart from that, we've also got registries, okay? And here you can actually go and add and define your own registries, public or private, okay? What I'm going to work on today is basically this WordPress application, which I've got defined here. So I've defined the registry. I can edit if you so wish, and I'm looking for a certain filter. So Bitnami WordPress 5.9*3, okay? So this registry has been scanned, okay? And it's already found the same thing, right? It's found all the vulnerabilities that are on each specific package within this image, okay? So at the same time, apart from this view, we also get this a different view on the actual security itself. So if you are going to security risks and vulnerabilities, basically you're going to get an aggregated view of everything that was mentioned under assets, platforms, namespace, nodes, and containers and registries. So this is just basically a different view, okay? So under vulnerabilities, as you can see, you can filter, you can do some advanced filter. So it basically tells you which, if I go from one to the other, it tells you all these images that are impacted. If this CVE is also found on a node or on a container or so forth, it also be showing it here under impact. Of course, you can actually do advanced filter. For example, only show me the ones who have a fix, without a fix, which have a score of higher than 6, for example. Okay. The same thing under compliance. Okay. So as you saw before, you got the compliance, where you got all the report of the compliance, and here you can have all respective containers that are exposed to compliance standards. And these are the compliance standards that we actually scan for. Whilst we are here, as you can see, there is a D410 that says ensure secrets are not stored in Docker files. Okay. And if we look at the impacted containers, we can see the WordPress application, right, which you actually saw within the specific pod before. Okay. Just to complete this bit, under notifications tab, for example, if I go into risk reports, and if I look for compliance container violation, is it this one? Yeah, for example, I think it's this one. No, I think it's one of these. We'll also have the same thing for the WordPress application that tells you, oh, okay, look, here you've got an issue of a compliance issue running on this specific container, and all this information that you actually see here is basically something that you can interact and inject into your monitoring, into your help desk system, and into your SCM systems. And all this is configured under specific settings. So being aware of this information, once again, if we go back to compliance, being aware of this information is crucial. But should we really be deploying such images in our production environments with, in this case, embedded hard-coded secrets? Well, as Carsten said before, and he's talked about the importance of secret management, I don't think so. So how do we going to stop this? So taking the secrets bit away, which Carsten is going to do the demo after, if you recall during the presentation, I briefly touched on the new vector admission controller and how SUSE new vector adds extra functionality within the admission controller concept. So I've shown you so far everything from the scanning perspective, but also need to do it from the runtime security defense. So runtime security concept, for example. So under a policy, we've also got things like, you know, network rules, response rules. So for example, response rules, meaning what do you do once an alert is discovered, for example? What happens if a CVE is discovered running on the cluster? You can basically potentially quarantine the pod, right? It's just an example. That's a very popular use case, right? We also do, of course, data loss protection sensors, WAF sensors come out already out of the box, okay? Like sensor card and the WAF sensors for the Log4j already out of the box. But what we're interested today, as I said, is in policy admission control. So under policy admission control, I've actually created this rule 1001 that's actually named image compliance violations. Okay, so let's just edit this. And what does it say? Image compliance violations. I've got a couple of criterion. I said image compliance violations is true. So basically something that an image is not compliant. I'm looking for something that is going to try to be deployed in a namespace test or WordPress. You can make this criterion very complicated, for example. You can actually select via the number of CVE scores, as I mentioned before, environment variables with secrets, for example, something you're trying to mount a specific volume, PSP best practices. This is a combination of, for example, running as root and so forth and so on, yeah, as you can see here. So you can make this string, this rule, as complicated as you actually wish, okay? But I don't want to do anything like that. So let me just cancel out of that, okay? And at the moment, I've got this rule set to protect and deny, okay? So it means basically if something falls within this image compilation, if an image compliance violation is found within one of these namespaces, then it's going to be protected, therefore, and denied, not being able to be deployed. I can actually go in here and actually enable it, but let me just enable it from here. Okay, so it's enabled. See? Right. So rule 1001 is ready. Let's go back to the actual, so as you can see, my WordPress application is still running. Okay. And in order to actually go and redeploy this application, I could actually go and redeploy the application from scratch and recreate the deployment and so forth and so on. But this is just going to take longer. So what I'm going to leverage is pretend that I've actually, the application has crashed and Kubernetes is going to do the actual self-healing. So what I'm going to do is I'm going to go into my workloads, into my specific pod, okay? And what I'm going to do is delete this application pod, not the MariaDB pod, because this is the one here that actually matches the rule and the actual compliance violation that we saw. So what I'm going to try to do is I'm going to go here and I'm going to delete the pod. Let's force delete because let's be quicker. So normally speaking, now what would happen is that you know, Kubernetes will do the self-healing, right? Because the deployment says I need the application pod as well as the database MariaDB pod. But where's it gone? So basically it hasn't been recreated. I'm going to go to deployments and I can see an error in here saying that the creation of this pod has been denied by the validating webhook. So this is the admission controller working. I can also go into the cluster itself and I can actually see the same error in here as well. Once again, this can always be put into your monitoring or CM systems or help desk systems and so forth. Okay. Last test, let's press return. Oops, it's not there. Of course, the application front end is not there at all. So let's see what's happened within New Vector itself. I go to New Vector, I go into notifications, and I go into risk reports, and I see the rule here. If I click on that, I see that the creation of Kubernetes blah, blah, blah is set to net because of the deny rule number 1001, which matches this specific criteria. Okay, please review your image compliance report. So I think that's actually pretty powerful. It goes a lot more than the native admission controller. Okay. So it's there. If I'm going back to my network activity pod, if I click, and you saw that I did not do anything specifically, right? I did not, this is not a trick. This is a real life demo. This is not recorded. If I press apply, and there you go. I'm looking for something within the namespace WordPress, apply, and of course the MariaDB pod is there by itself doing nothing at all. As a matter of fact, if I click on the red dot, I can also have a look straight away, also another different view of all the CVEs with high score and medium score as well. Okay, so MariaDB is by itself. So let's put back everything together, okay? Because I'm not going to basically change the image. So I'm going to let's put everything back together. So if I'm going to go to the policy admission control, I'm just going to disable this, okay? So basically, as you saw so far, that an image with a compliance violation with hard-coded secrets did not get deployed via the admission control, okay? Nothing to do with secrets management itself, which Carsten is going to touch on. Go. So everything's there. I've disabled this. I'm going back to my deployment, and I'm going to my workloads, deployment, and here, what I'm going to do now is I'm just going to deploy. Of course, the pod is still missing, okay? And basically, in this case, I have to go and redeploy again. So I'll redeploy the application. And this is going to take about 20 or 30 seconds. So hopefully it won't be too long now. I'm looking at the pods. Of course, Kubernetes is doing specific work. Won't be too long. Normally takes 40 seconds, Carsten. It gives you some time to get rid of your COVID blowing your nose. 37, shouldn't be too long. Okay, so it's up and running, deployment's up and running. If I press refresh, of course, the image got deployed. Okay, so it's all working fine. Let's go back to the network activity tab. And basically what I'm going to do is I'm going to check for the WordPress again. And as you can see, the picture is looking a little bit different because now not only I get the WordPress application, oops, let's just try to fit this. Oops, let me just try to fit this correctly. Okay, so I've got my MariaDB, which is by itself before. I've got the WordPress and the connected to the worker, but there's one link they're missing as well. So I press refresh, I'm going to see the external connectivity. So basically this is the external connectivity once I've done it here. And of course I can actually try to click on it. It tells me, okay, so my 1042.139, which is basically my IP, is connecting via to the server WP-CSK/, which is an IP address hosted in Germany. So, and as you can see, all the relevant connectivity as well, right? And the last bit as well, how does this specifically work? If I'm going to go back to my policy, if I go to the groups, if I look at my WordPress, for example, my application, as you can see, I'm seeing all the process file rules discovered. So this is the runtime security, all the file access rules, all the specific network rules, which basically match from this pod to another pod via this application protocol over the specific port. And from here, for example, then you can start exporting the group policies and then you start using this configuration. This is only your trusted source going forward, and this is the concept of your own application signature. That's all from my side, Carsten.
Okay, thank you. So let me share my screen now. This one. Okay, so let's head into the Vault part. So Claudio now really good explained how to detect containers, which include static secrets, and how to get rid of them. Now the question is, how can we make that secret not static? How can we manage that secret with Vault? I really like webinars or workshops where people can follow along. So therefore, I've created a GitHub repository with all my documentation. So if you are interested, you can go to this URL here and try this yourself. If you have Rancher installed, this should guide you through all of this. So basically, what have we done, or what have I done? So first, of course, I've installed Vault. So as you can see here, Claudio gave me access to his Rancher environment. And within this environment, under workloads, you can see Vault is running here. So I've installed Vault via Helm, did some changes to the values file, but that's basically it. My values file is also here as an example. Then I've followed the, so basically this is based on 2 tutorials. Then what have I done? Of course, first I have to configure Vault to be able to authenticate with Kubernetes. So I've enabled the authentication method for Kubernetes, and I configured it with a policy and a role, and then I've created a secret to test everything. So as you can see here, this is the Vault UI. When we go into the Vault UI here under access authentication methods, you can see the authentication method for Kubernetes is configured here. These are the 2 roles which I've created here, and everything is configured properly. So for example, so here's a role. The first role for one test, and that's another one for another test. So okay, so first, what we're going to do is use the Vault secrets operator. And the Vault secrets operator is not installed by default. If you want to use that, you have to install it via its own Helm chart. So I've did this as well. As you can see here, the Vault secrets operator controller manager, long name, is running here as well. And I've created then a namespace for this and applied these 2 files. And now I want to have a look into this. So the operator is using the same authentication method and is using this role here to authenticate to Vault in this case. And what I've done here, first I've created this Vault aus static. And as you can see here, I've specified the method, the name of the method, the mount point, Kubernetes. As you can see here, this is Kubernetes, and then role 1. The name of the role 1, and the service account in Kubernetes. And this just creates a connection. This creates authentication connection to Vault for the operator. And then when we want to actually create a secret, what we can do is we can create, for example, here, use a kind static secret, Vault static secret. So this is a key value pair. And I've defined here the type, KVV2, the path, KVV2, and then the path of the secret itself, web app/config, and the destination where I want to have that secret. and that's now the name of the secret in Kubernetes. I've also defined the refresh rate so that it will be refreshed every 30 seconds, so quite frequently. Yeah, because for the demo, I don't want to wait five minutes for an update. And here we configure the authentication method, which refers to that what we've created before. And yeah, everything happens in the app namespace. So when we look now into Vault, we will see there's a secret engine, mount KVV2. So it's this one here, KVV2, web app config. That's what we've configured here. Within that, we have two key value pairs, password and username. And when we go into Rancher, on storage secrets, yeah, you can find the secrets here. We will see in the namespace app, because that's what we've configured here in the namespace app. We will have a secret with the name secret KV. And that's also what we've configured here. And when we go into that, we open that, you can see, oh, that's actually the same value here. Now that I've set the refresh rate to 30 seconds, we can just change this password, for example, and we should see an update here quite immediately. Yeah, should not take longer than 30 seconds, and I think it does update automatically here. I don't have to reload. Or let me try to reload. Maybe I have to reload. I don't know. Yeah. So, but after, oh no, now it happened. Yeah, as you can see. So now it was updated, and within 30 seconds, now it's updated. So the benefit here is you can manage all your secrets via Vault. You can inject them into secrets in Vault. That's in Kubernetes, into Kubernetes secrets. That's useful if you have applications which already use these secrets and you just want to move that management of the secrets to Vault. For example, so now I've just used a key value pair, but I could also just use dynamic secrets, completely dynamic secrets. For example, database credentials. So just-in-time credentials. So Vault has different kinds of secret engines, as you can see here. You can create just-in-time database credentials with this engine, and then you would have dynamically created credentials after a short period of time for your database. That's quite convenient. So now let's have a look into the other example. With Vault, when I installed Vault, I automatically also installed the, I've automatically also installed the Vault agent injector, because I've configured that in the values YAML file. And the Vault agent injector enables me to directly inject secrets into a pod via a sidecar container. So in this example, I have another application here running, which is this container here. As you can see here, when I've created that container, the Vault agent init runs through, and then it started that thing here. We can execute a shell here. And what have I done? I've created another secret, internal database config, also some secrets here, db secret password, db read-only username. And let's show the deployment itself here. And I've created this YAML file here to deploy the application. So basically, it doesn't look so special. The only difference here is it does include some annotations. So basically, we create this pod with this service account, but in addition, we have some annotations. So first we say, okay, we want to inject the agent with true. We want to bind it to that role here, internal app. Yeah, remember, that's the role which I've showed before under the authentication method. I've set the render interval here to 30 seconds so that it will be updated after 30 seconds. Then we set the path here to where to get the secret from. We want to get the secret from internal database config. So that's where we are here, internal database config. And what we're going to do with this, we create a template and we write that template. And this is the template language here. So with the secret, we create a template which includes the string. And basically, that's a Postgres connection string with placeholders for the username, with placeholder for the database, and yeah, just a Postgres connection string. And if we go into this and now open this file here, Vault Secrets Database Config, that's where it stores database config, stores this stuff. Then we can see here's a connection string which we've created. So PostgreSQL DB with only username, DB secret, that's exactly the connection string, but with these placeholders replaced with these values. Of course, what we can also do now is we can change the secret. Change the password here. And it will take some time. Yeah, as I said, 30 seconds is configured currently. So we have to wait 30 seconds. Now it's already updated, so we can see DB with only username and password is streng geheim, which means in German very secret. So now it's updated. So I think this is an even more convenient way how to use Vault together with Kubernetes, because it can directly inject the secret into your container. You can even inject, for example, database secrets directly in a configuration of, for example, WordPress. Yeah. So as Claudio has shown in his previous example, WordPress requires database credentials. He had a database there, and with this we can make this completely dynamic. We can use the secret engine here for databases and create dynamic credentials completely dynamically with a short TTL and use that instead. One of the benefits also is that if you want, or let me just go one step back, a deployment usually consists of one or more pods. What you can also configure is we have an individual secret for each of these pods. So in my case, I only have one, but I am also able to configure this when I have dynamic connections to have an individual one for each pod. So that makes it even more secure overall. Yeah, I think that was my demo. I have in the slides also some of this explained. Yeah, Claudio, conclusion. Yeah, what can we say? I think SUSE and HashiCorp, works pretty well together, right?
Yeah, correct. Exactly. I mean, each specific solution brings its own benefits, right? So HashiCorp Vault brings all the secret management, which of course, as we know, Kubernetes does not do native secrets management. So HashiCorp Vault is the right tool. And then you've also got other tools that actually prevent these, unwanted type of images to actually be deployed in production, number one. And of course, you also need to have some visibility of what's happening in production. This is where New Vector Prime and Rancher Prime can actually complement the whole container security story.
Yeah, I also think really that it's a really good combination. Vault is, I would say, de facto standard for secret management. especially in Kubernetes, but not only in Kubernetes. It was for a long time. It was not as easy to use Vault together with Venture, but now it works really good together. Yeah, I'm really happy that we did this here, and it was really fun to try to see how both tools can support each other and make the Kubernetes environment even more secure. If you have time, we would also like to invite you to the HashiCorp in Boston, October 14th to 16th October. It's an on-site event, and yeah, SUSE has also the so-called SUSE Venture and SUSE Vector rodeos. Yeah, Claudio, can you tell us a little bit about that?
No, sure. So basically, if you're not actually familiar to the whole Rancher New Vector story, SUSE holds these regular rodeos. So this is done in different languages in different time zones. And this basically is like a really hands-on exercise. So it's a 3-hour remote type sessions, absolutely free. People sign up, click on the link that you're going to get in your PDFs in your emails if you attend the session. And then sign up, and this is really going to be a hands-on session, how you actually handle Rancher Prime, cluster management, cluster deployment, as well as the whole new vector security, which has similar examples or other examples than the ones I've actually showed you to actually make sure that your clusters remain secure. Yep. That's it.
Okay. Yeah. Are there any questions? So if you have any questions, please write them in the chat now. Let's say we still have like 4 minutes left. Otherwise, we would start now. Stop now. No questions. Okay,
No
then
questions.
thanks everybody for attending. Thank you, Claudio,
Thank you.
for working together with me. That was interesting. Yeah, it was a lot of fun. And yeah, thank you very much, and see you next time. Bye bye.
Thank you. Bye bye.